Hello again, everybody. My presentation is devoted to the application of agroecological crop protection against arthropods, pest arthropods. And for that, I'm going to, to present three parts. Specific part. One is devoted to the case of organic agriculture on chayote. Chayote is a cucurbitaceae, a cucurbit. It's called, I think, su in Vietnamese. The second part is devoted to mango, agroecological crop protection in mango orchards, with a special focus on socio-economic aspects. And from these two experiences, we'll try in the third part to get some generic lessons that could be useful for other experiences in another context. I would like to stress that it is only the strict declension of the principles of agroecological crop protection into practices. And you remember that three words are very important for me. Order in the declension of the strategy in the field, of course, ecology, and also consistency between the words and the deeds. First part, the advances in organic cultivation of chayote in Réunion Island for now 10 years. So this part is focusing on chayote and on organic farming. Chayote is a patrimonial and very popular crop in Réunion Island. It's a cucurbit consumed by most of the people daily. And since the 80s, the crop was, we use a lot of input such as fertilizer and pesticide and also irrigation. And the crop was carried out on, with under trellis, and of course the consequences were quite immediate. The decrease in the yields, increase of pests and mostly fruit flies, non-sustainability in these kind of agroecosystems, and with a drastic reduction of cultivated surfaces in chayote. So the issue of this study was to try to adopt the agroecological crop protection approach for this kind of crop, and if possible to see if it's compatible with organic agriculture. And these presentations focus mostly after 2 years of this experience on technical, socio-economical, environmental, but also sanitary and ecological results. Three phases, you remember. The first one, it was about 10 years ago. It consisted by co-designing the approach with all the actors, from research to farmers, via policymakers, extenders, trainers, teachers, experimentators, and so on, with the principles of agroecological crop protection. I remind here two axes: biodiversity and health of the soil, to three pillars: prevention, habitat management, and conservation, biological control, and field strategy where the priority is given to preventive measures. The phase one was situated in the Salazie area, which is a circus. It means quite a unit of with ecological characteristic and it's the basin of production, the traditional one of chayote in Réunion Island. Phase 2, it was between 2009 and 2011. It was devoted to apply project in partnership to try and to evaluate the agroecological practices with different partners from research to extension, and with the farmers as the centers of gravity of this approach. And the phase 3, from the end of the project till now, which focus on the transfer and the adoption of agroecological practices. So with a role very important from of the extension partners and the policers. Now for some results. First one concerning the fruit fly status, because the problem of Chayotte about 10 years ago was fruit flies, very high population and damage. So the Chayotte is attacking by 3 species, Bactrocera cucurbitae, Dacus demeresi, and Dacus ciliatus. And the first result we obtained, as soon as we stopped the treatments of insecticides, is that we saw that only one species was able to develop inside the Chayotte fruit, Dacus ciliatus, while the 2 other species, Bactrocera cucurbitae and Dacus demeresi, cannot develop inside the fruit because of a defense reaction of the fruit. So why too much damage of fruit flies? We implemented some nets under the trellis to collect the fruit which fall down, and the large majority, 93% of fallen fruit, didn't show any trace of fruit fly damage. So it means that they fall down not after an attack of fruit flies. But after they fall down to the ground, they became to be very susceptible to fruit flies, because they give some pheromones that attract females of fruit flies, and they can easily come and lay eggs in this fruit. And so this fruit fallen on the ground became reservoirs of new generation of fruit flies, giving, of course, high damage of fruit flies in the crops. So for us, the fruit flies population were not a cause of the decrease in yield of Chayotte, but only a consequence. And the cause of yield losses for us was physiological shedding. It means if you put larger amounts of input, such as fertilizer, such as pesticide, and so on, you will get a high production under the trees, and the plant is not able to develop all the fruit towards their maturity. So a percentage of this fruit fall down and so becomes reservoir for fruit flies. So the first recommendation we gave to farmers was to reduce the physiological shedding by reducing the amounts of inputs, and mostly the amounts of mineral fertilizer, and in this fertilizer mostly nitrogen. And then the second recommendation was to pick up the infested fruit on the ground in order to break the life cycle, to reduce the level of population of the next generation of fruit flies. Now for the results for the practices we implemented, that farmers implemented, but I say we because it was a collective and participative approach with a lot of partners. First of all, the suppression of chemicals and mineral fertilizer, also to be consistent with the organic agriculture standards. Second package is agroecological components. You know them very well now: sanitation, biological conservation, biological control, and habitat management. And thirdly, other practices, of course, compatible with organic agriculture. So now you will see it's exactly the strict declension of the principle of agroecological crop protection. First of all, suppression of pesticides, insecticide, and herbicides. Then a preventive measure, what we can call sanitation, using a technique called augmentorium. The aim is to break the life cycle of the fruit flies populations, because each, as I said before, each of the fallen fruit represents a lot of flies that can potentially infest by the next generation the crop. So this technique consists to pick up the infested fruit on the ground and then to throw them into this augmentorium. The augmentorium, as you can see on the slide, is like a tent with on the roof, as you can see, a net with a specific mesh. If you see to the mesh, when you when you throw infested fruit, you will have emergence of fruit flies of a new generation, and they will be sequestered in the augmentorium, and the mesh of the net is sufficiently small to avoid the escape of these fruit flies. So they are sequestered in the augmentorium and they die like that. So it's a very effective technique as a sanitation technique one. But the mesh is also sufficiently large to permit that the escape of some insect smaller than fruit flies, such as parasitoids. And as soon as you stop spraying insecticide and herbicide, the level of population of parasitoids comes back, and they can reestablish a balance between the population of fruit flies and the population of parasitoids. So the mesh of the augmentorium, of the net of the augmentorium, is very important, both to avoid the escape of fruit flies and to permit the escape of the parasitoids. So we can say that it's also a tool of biological control. Then concerning habitat management, in order to improve the biodiversity in the crop, by suppressing herbicides, we have a spontaneous permanent vegetal cover, which is very interesting for some generalist predators such as ants, spiders, Dermaptera, and so on, which lives in the cover. The same thing for the suppression of insecticide. As soon as we suppress insecticide, we have a comeback of natural enemies, but also other groups such as pollinators, and also not only insect, but as you can see on the slide, we have the comeback of chameleons. Chameleons in Réunion Island is very important. It's a symbol of this island, and it means it's an ecological context. And of course, you have also, by the use of augmentoriums, the increase of the population of parasitoids. For example, in this picture, you can see that under the trellis of Chayot, on the soil, you can have a lot of high population of spider, for example. On the trellis, you have also other species of spiders, and you have a lot of chameleons. And as soon as, I think it's a very good indicator to know if the crop is sprayed or not. As soon as you stop spraying insecticide, you will see the comeback of chameleons. Concerning the technique, you can also adopt some IPM techniques, such as this one, for example, male annihilation technique. If it is not forbidden in France, it's not so clear to use this technique. We can use for monitoring, but not for trapping flies. This technique doesn't use insecticide at all, only parapheromones that attract the males of certain species. And we can also use protein baits that kills adults of fruit flies if necessary. And of course, we have to take care of the health of the soil by using amounts of organic matter. We have take care a lot of the needs of the plants before for several decades. Now we have to take care of the health of the soil mainly by using organic matter for improving its health. Now for socio-economical results, as you can see, as soon as you suppress insecticide, and mineral fertilizer, you are going to reduce the level of fruit flies, and you are going to increase the yield. If you say to farmers at the beginning, maybe if we suppress the pesticide, we will have an increase in yield, he cannot believe that. So it needs time to discuss with all the actors. But in this case, the suppression of pesticide and the implementation of agroecological practices imply increase in yield. You see, near 50%. So it's very, very important. About the cost, it was 4 times cheaper, and for the time of protection, it was about the same thing. We registered great satisfaction of farmers because they discovered the tool Augmentorium, and they saw that the vegetal cover is a very effective technique. And they also are interested by this kind of practice of approach, because for the socio-economical reason you saw before, it's easier to implement in the field. You save a lot of money, and also they appreciated the improvement of health of the soil. But we notice also that farmers need to have a training program, to have discussion, to have exchange every time with other actors, between farmers, but also with actors such as trainers, such as extenders, such as scientists, and so on. Satisfaction of a consumer, because they now can find safe products of Chayot. And it's also compatible, consistent with organic agriculture. We have also some tools that have been developed by extension actors and policymakers, such as economic and environmental interest group. This tool help farmers who want to work together more collectively in an agroecological approach. We have also implemented a professional qualification university certificates devoted to farmers. So it means about 35 hours on agroecological crop protection principles and practices. And after this time, the farmers can get a diploma delivered by the University of Réunion. This training program is given by different actors. And we saw that when a farmer is graduated and he comes back to his village, then he becomes easily a leader in the area, and he can also train other farmers. We have also classic tools. I don't want to spend too many time. I prefer to stress on this one because it's quite a new one. It's a model, a qualitative model, very easy to use for farmers, and it's a new tool, new concept of tool that can permit to exchanges, if you want, between, for example, extenders and farmers. And it's very useful to understand why, for example, pesticide is not effective against fruit flies, why, for example, sanitation is the most effective practices, why this factor is important, and so on. And farmers can use this model because it's a very easy, useful model for them. So we can get this way for the training of the farmers. We have also we had also during this experience large support from the policers, with of course logistical measures, but also financial incentive for example, conversion to organic agriculture, but also to maintain organic agriculture, and with aids in the production of organic shallot. And the result, as you can see, is that we had nothing under organic agriculture standards 10 years ago. And now we have about 60% of the production under organic agriculture, and among the within the 40%, 20% are under conversion. So it means that in some years, all the production of shallot will be under organic agriculture. In conclusion of this part, we have a very, very good result with development of a patrimonial crop, shallot, the promotion of organic agriculture in this area. It means not only on shallot but also on other crops such as citrus, such as vegetable, and so on. We saw and we could demonstrate with farmers that the organic practices could be effective, cheaper, sustainable, and could be very well adopted by farmers. These approaches took into account health and ecological criteria, and it has, of course, an impact of the development of organic agriculture, but also on agroecological crop protection development in Réunion Island, but also in the other countries in Indian Ocean. It brought also very interesting social interest from the habitants, the citizens, in organic shallot production. And now you have a very important celebration of shallot in Salazie each year, with the election of Miss Shallot. Here is Miss Shallot 2017. So that was for the first example. The second one is another one. It's on mango. And it's devoted to the social and economical results. So it was presented in a recent international symposium in Malaysia with different colleagues. Mango is also a patrimonial and very popular crop in Réunion Island, but for now 2 or 3 decades, with the Green Revolution, there was an intensification of this cropping system, with increase in use of chemicals, fertilizers, water, and so on. And so it implies some phytosanitary problems. Now you are not surprised with that. You know that more you put in pesticide, more you will have problem with pests. So we had problems with the sustainability of mango orchards in Réunion Island. One other thing is that we have a large spectrum of different pests, not only insect or arthropods, but also pathogen, bacteria, fungi, and so on. And we decided to take into account all the spectrum of this pest. We just applied, as before, the principles of agroecological protection, the strict declension. And our hypothesis was the following. To break to fight against pests for getting a good production. Before, during decades, we used agrochemical crop protection, and the hypothesis was to replace agrochemical crop protection by agroecological crop protection using habitat manipulation, favorable for beneficials, and if possible, unfavorable also for pests. And that was possible by designing and implementing some agricultural practices, such as the practices you know now, preventive measure, habitat manipulation, and conservation biological control. The three phases, co-designing and an agroecological approach during 2 years, 2010-2011, with the same principles. I don't stress on it. The location was in the basin of production of mango in Réunion Island, in the west part of the island. The second phase was to focus on applying a partnership project of research and development with a lot of partners, and with 13 pilot farmers who were the center of gravity of this project. And after that, since 2015, the project, the phase, is devoted to transfer and to policies for adoption of agroecological innovations. So now for the results, the same adoption and application of the principles. First, not increasing pesticide, but just suppression or high reduction of pesticide, and not only insecticide but also herbicides. Second thing, the management, for example, of fruit flies based on chemical before is now based on sanitation, as you saw on the first experience in Chayotte. Just a small slide to show the story of Mr. Payet. Mr. Payet is a common name in Réunion Island. So Mr. Payet is a producer of mango. He picked up the infested fruit fallen on the ground. Then he threw them in an augmentorium. In an augmentorium, you have an emergence of a new generation of fruit flies, but also you can see smaller insects that are parasitoids that exist only if you have no pressure of insecticide, of course, and the mesh of the nets permits the escape of parasitoids that can infest the crop, but this time positively infestation, and that also avoid the escape of fruit flies. So here is a slide on the mesh that you can see only parasitoids are outside, and you can see the eyes of the fruit flies inside the augmentorium. The second thing about insertion of biodiversity with implementation of permanent vegetal cover. You know, you have just to suppress herbicides, and you have a spontaneous vegetal cover, and after you have just to cultivate it as a crop. You have to irrigate it during the dry season and so on. We have used also some other types of habitat manipulation, using, for example, flower strip to enhance the level of population of parasitoids, of non-pest herbivores, and of pollinators. We have also implemented habitat management via trap and refuge plants such as, for example, a trap for pests, such as maize, on the top, on the left, for fruit flies. And for example, on the bottom, on the left, you have a refuge plant, which is pigeon pea, which is quite attractive for beneficials and, for example, mostly for syrphids. We have also, it's quite new in Réunion, but we have also intercropping now in mango orchards. For example, with a mixture of mango, of passion fruit, of cassava, and as you can see, with a lot of wheat also, and a good production of mango. And of course, all these practices of habitat management have a very good impact on the level of beneficials. And we can see the comeback of a lot of beneficials, such as, for example, on the top right, syrphids, on the bottom right, bug predator, and at the bottom of the slide, pollinators, bees. Here is an example of interaction between a female of fruit fly and a female of parasitoid. On the slide on the left, you have in red a female of fruit flies laying eggs under the skin of the mango fruit. And in blue, you have the female of the parasitoid, which is waiting. After the female of fruit flies lays eggs, the female of parasitoids is going and look for the eggs. And when it finds the eggs, then the female of parasitoids lays eggs in the eggs of fruit flies under the skins of mango. We have also, I don't want to stress on that, IPM, such as before, techniques, such as male animation technique, protein baits, and of course organic matter to improve the health of the soil. And it's exactly the same thing. We have now to take care of the health of the soil and not only of the health of a plant. About the appropriation by the farmers, they really appreciate the effectiveness of augmentorium, even if they have to do that collectively in a collective approach. They appreciated also the permanent cover, the interest in production and workforce also, and they noticed the health of the soil is very important. They appreciated these agroecological practices also because they reduce the cost of production. But they also need action in terms of training and information sharing. We didn't register production losses during the 3 years of a project, and the cost of production were reduced by 35%. In terms of use of chemicals, in France we have an index which represents the pressure of chemicals. It's called the treatment frequency index, and it falls down from 22 to 0. So it means we are now we can grow mango and cultivate mango without pesticide and mostly insecticide. We have also some ecological data, quite original. We have collected large numbers of arthropods. Here it's 126,000 arthropods. And among these arthropods, we identified about 800 morphospecies of arthropods. And among them, you have only a very few number of pest species. On the contrary, you have a lot of species of parasitoids. We identified 190 species of parasitoids. So you have a balance which is re-established between pests and beneficials. We have now a better knowledge on the biodiversity, for example, for spiders, for bugs, for coleoptera. We have also tools such as guide, booklets, posters, CD, and so on. We have an original tool which is called DefiFerm, network. It's a network of farms where the agroecological practices are implemented, and it can be used for training programs for farmers, for extenders, and so on. We have also the same kind of interest group that we saw for Chayotte, with a collective and agroecological approach for farmers in the same basin of production. We have some measures. For example, if a farmer implements a permanent vegetal cover and flower strips during several years, he will get some aids from the policers. This experience was a promotion, consisted in a promotion also of organic agriculture, because we suppress the pesticides, we suppress the fertilizers. We can use organic matter, and we improve the soil health and the biodiversity, which are also the same basis for organic agriculture. So this experience helps also the development of organic agriculture on other crops. We have implemented the same professional qualification university certificates that I talked before for Chayotte. Now it's delivered for 6 years, so we have a very good result with that. And in conclusion of this part, I would like to stress that we have now tools to develop the crop of mango. The production is not enough if you compare to the demand. So with this approach, it's possible to increase the production of mango in Réunion Island without increasing the amounts of chemicals. We have also the development of organic agriculture, and we have a very important role played by extenders and policymakers that aid the development of such this approach. So now, just to conclude on these two experiences, I would like to ask a question. You can answer if you want. Can we get some generic lessons from these experiences? So it means for other contexts, for other crops, as you can see on the slide, you have different crops, different contexts. Can we get some lessons useful for the transition period of agroecology? 3 points, 3 parts. The first one is devoted to the case of agroecological transition. You see that you imagine that it's not to push on a button and to have an immediate result, but it needs time. So there is a period to shift from agrochemistry to agroecology by a period. We don't know how is the duration. And we have some case for that. These cases are given in the book, and as you can see on this slide, where is the biodiversity in this crop, and what about the soil health in this crop? So you can imagine that it needs time to move. It also needs mentality and habit shift, for example, because we have habit, we have use, and it's not easy to change for farmers especially. And in the book, Agroecological Competition, you will find the chapter 5 is completely devoted to this case of agroecological transition. So I don't stress on it. I come to the drivers of innovation adoption. And I don't want to read this table, but it's an analysis of different experiences in Réunion Island, on Chayotte, on also on cucurbits such as zucchini or pumpkin, and on mango. What are the components of the agricultural system? What are the variables? And what are finally the drivers of adoption by farmers? And here is a table showing that you have drivers coming from the cropping system, the type of cropping system, for example, perennial or annual. Criteria coming from the practices. If you have a practice which is easier to implement, the adoption will be easier. You have also characteristic coming concerning the farmers, of course, their level of training, their level of working together, and so on. And you have also characteristic coming from the market or the sector. For example, if it's a patrimonial crop, you have a demand, so the price is good. And for example, it's the case for chayote and mango, but it's not the case, for example, for zucchini. So you can have a good adoption or a bad one. And as you can see on this slide, and I think it's a good result for us, we have a good result of adoption for chayote and mango, as I showed before to you, but we have not good adoption for zucchini. And we know why. Not for technical reasons, but for social, market, and types of cropping system. So it's very interesting to use these results if we want to adapt this approach in other context. And so you have on this slide, I don't want to spend too many time, I'm too long, the different criteria, such as an investment strategy possible with perennial crops, the simplification of cultural practices, the level of farmers in terms of knowledge, training, exchanging, working together, the market and the possibility to export production, the heritage value of the crop, such as chayote and mango, and of course the role of the policy makers with incentive, for example, organic farming. And here is a description of the failure, the case of low adoption in courgette, in zucchini crop. Now, last word to conclude about communication to all the actors. It's important to communicate the result, these experiences to most of the people. And as you can see on this slide, you can communicate towards professionals, scientists, students, pupils, and young students, general public, and so on, by a lot of tools, as you can see on this slide. Of course, I've taken some examples, a guide to recognize pests and beneficials. That is interesting, the shift in perception of what is an agroecosystem for a farmer. Here it's 10 years ago. For a farmer, he took attention to the mango and to the pest, and now he takes attention to the mango, to the pest, but also to the mango, to the weeds, to the vegetal detritus, to the predators, to the non-pest herbivores, to the parasitoids, and so on and so on. So he knows that it's a complex, it's a food web with different trophic groups, and he is looking for the best balance that he can implement in the field. We have also a training program, as you can see on this slide, serious games, which are funny and interesting, international workshops, such as this one. It was in Myanmar in 2017. The use, as I told you before, of qualitative modeling, which is very important, which is very useful and simple to use by farmers. Information giving to children and pupils and students at the different levels. And also we are in progress. We have got a project of a public movie on agroecological crop protection experiences in Réunion Island by the movie maker Guy Lambert, who is a scientist from Aix-Marseille University in France. As you can see, and I thank you very much for your attention.